Welcome to Missouri University of Science and Technology. My name is Alyssa McCarthy and I'm the Chief Executive Officer. And this is the Mars Rover Design Team. The team functions like a small engineering firm with four main branches: executive, administrative, financial, and technical. The technical branch is split up into four sub-teams: telemetry controls, power, mechanical, and science. All the teams work together to create a great rover.
My name is Katie Brinker and I'm the Chief Technology Officer of the Mars Rover Design Team. This year the team is taking on an approach of iterative redesign for our new rover. This means that we're iterating off of our Phoenix platform, but also redesigning some new systems. This year we've been maintaining a power budget, weight budget, on-rover budget, and progress tracking spreadsheets throughout the whole year to ensure that we are on track to building a rover that's under 50 kilograms, under $15,000, and also that we're prioritizing our work so that we complete a rover that's competition ready. This year, the mechanical sub-team is taking a really innovative approach to completing our frame, suspension, propulsion systems, and our robotic arm.
One of the ways we're doing this is by looking at the frame and moving from an all-aluminum chassis to a hybrid composite aluminum frame that's made of carbon fiber and aircraft-grade aluminum. Another thing we're doing with the frame is focusing on wire routing and electrical placement to make sure that all the components that we need to succeed at competition have an allotted space within the frame. On the suspension, we're keeping the six-wheeled independently suspended approach, but we're pushing the design element further by taking advantage of three-dimensional manufacturing techniques like computer-controlled milling. The reason why we've redesigned so much of the rover and tried to cut so much weight is to make space for our new science experiment, our long-range camera gimbal, and our cargo deployment system.
The science team is responsible for completing the systems that will allow us to best compete in the sample return task.
The science team has analyzed sites for potential geological and biological significance. These sites include stream beds, alluvial fans, and mud cracks. After our site selection is made, we'll begin drilling with our new drill and drill sheath. The drill sheath is made of fiberglass, which has a temperature and moisture sensor embedded into it. That'll give us the ability to simultaneously take those readings as we're drilling our sample out. The samples that were deposited into the sample carousel will be removed. Some of the chemical experiments will include a nitrate test, a potassium permanganate test, a barium chloride test, and a hydrochloric test. These will help us identify different compounds or organics in the soil that might help us identify whether there was life present here or water.
The power sub-team focuses on custom hardware to meet our rover power needs.
So all power on the rover starts at our battery pack. And our battery pack this year consists of lithium polymer cells. We have them arranged in 8 modules in series, each with 10 cells in parallel. From the battery pack, our power moves to our battery management system, which monitors the state of health of the battery pack and monitors the voltage and current output of the pack. And from the battery management system, our power moves to our power board, which converts the pack voltage down to 12 volts, 5 volts, and also passes pack voltage through to the motor controllers. The power board also monitors the current output of each bus and monitors the pack voltage and reports these measurements to the base station. What's new this year is the battery management system also charges our pack, so we won't need an external charger.
Telemetry Controls has taken on a new platform this year that's really modular and really accessible to all members of the team.
With the recent advent in the marketplace of internet-connected small embedded chips, we've been able to build a device-centric model that allows us to quickly connect to a network, validate one control station with one device. That minimizes failure points, that decouples our devices, that makes it very quick to test and validate our systems. The biggest benefit of this is that once we've signed off on our device, we know it's good to go. The device modularity that we've seen on Rover translates to base station. Our C# program, RED, Rover Engagement Display, is actually a distributed control unit that deals over the internet protocol through modules.
In all we do, the Mars Rover Design Team constantly pushes the boundaries of engineering. We are more than just a team, we're a family. One team, one vision. We are the Mars Rover Design Team.
Today, tomorrow, forever.